edition of client-side web scripting. If you go back to the Learning Plan 1 and you open up the downloaded zip file, which is way at the top that you downloaded in a previous assignment, I want you to open it up and I want you to go up to Object-Oriented and click on Object-Oriented JavaScript. Now, many of you have gone through OOP 1 and an Intro to Programming, and so you've had some object-oriented principles pretty much thrown at you, drilled into you. But I want to talk a little bit in some more detail about some of these things, and in particular point out things specific to JavaScript. So JavaScript is an object-oriented language, but it's a little bit different than C# and Java. So I just want to make sure you understand that. C# and Java are very similar object-oriented languages, but they're what's known as classical object-oriented languages. So when you create and program in those languages, you're creating classes and you're putting methods in those classes and you're creating instantiating objects off of those classes and things like that. JavaScript's a little different. It is object-oriented, but it is what's called a prototypal object-oriented language. So you don't have classes, you have prototypes. And we're going to learn more about that as we go through. So right now I want to give you kind of the 30,000-foot view. Some of these terms you have already been exposed to, so I just want to point out some of the nuanced differences, and I just want to, again, kickstart our brain a little bit, thinking in an object-oriented manner. So again, an object, it's a representation of a thing. So I've got my little puppy here is representing, that's my common object, it's a dog. So he's my object. He has certain characteristics or properties. He has a color, he's black, he has name, her name's Maggie, and she has a weight. This little one, she probably only weighs a couple pounds, but she can bark, sleep, run, eat. So she has methods, some actions she can do. So in object-oriented programming, the characteristics of an object are properties in OOP, and the actions are called methods. Now, I'm going to throw around some terminology because there is some differences in terminology when you talk about a prototype object-oriented language like JavaScript versus a classical one like C# or Java, but they're almost identical. They're just different terminologies based on different languages. So, in other words, objects are most often named using nouns, an animal, person, place, or thing, whereas methods are verbs, eat and run. So my dog eats. So the dog is the object. The eats is the method that the dog implores. And then values are usually adjectives. So my dog eats fast. So a property is he's a fast eater. But being fast at eating doesn't necessarily mean he's actually eating. It's just a property, a characteristic of that object. Now, just so you know, in classical object-oriented languages, and I have this noted here, like C# and Java, properties are referred to as fields. So if you come from the OOP 1 and C# background and you recall my colleagues talking about fields, when I refer to properties, it's fields, same thing, but in JavaScript we call them properties. So if we take this sentence right here, the black dog sleeps on her rug. So the dog, that's the noun, that's the object. Black, the adjective, that's the color of the dog, that's the property. Sleep, that's the action or method, or in JavaScript sometimes we refer to them as functions. And then on a rug, that could be a parameter passed in to the sleep method. Where are you going to sleep? Sleep on the rug. So just wanted to kickstart some of those things. Now, some other things having to do with object-oriented programming. We had classes, and I'm not going to read through all this. I expect you to read through it. But there are some differences I do want to point out when it comes to classes in classical object-oriented languages like C# and Java versus prototypal ones like JavaScript. And I highlight that kind of in this last paragraph, but I want to make sure you understand that in JavaScript nearly everything is an object. So there's no such thing as a class in the sense that if you come from C# or Java that you know of a class. So everything's based off of an object. So JavaScript has prototypes, which are also objects. So in classical OOP languages, you'd say something like, create me an object called Bob off of a class named man, or something like that. In prototypal object-oriented language, you'd say, I'm going to take this object man and I'm going to reuse it as a prototype and basically copy it into a new object called Bob. So if you have a background in classical object-oriented programming languages. To kind of wrap your head around a prototype and how prototypes work from a JavaScript standpoint, think class equals prototype. Now, it's not a one-to-one equality conversion here, but it'll help you wrap your mind around that a little bit. Don't forget about encapsulating things into their own private methods, public and private. Now, when we go through functions and stuff, we'll talk about scope and public and private, but those things still apply to JavaScript. So keep those things in mind. The concept is still the same, but you approach it a little bit differently from a prototype standpoint. So the implementation is a little bit different than in Java or C#. And then aggregation, just remember we can aggregate, and we are setting you up from a modularization standpoint to be able to aggregate things together. Reusability and inheritance, we're going to talk about that a little bit with functions and things, but we can reuse code. Now, in classical object-oriented programming, classes can inherit from other classes. But in JavaScript, there are no classes. Remember, I just mentioned that. So objects can inherit from other objects. So you can inherit, that new object can add or extend the parent object. So you can have, in my example here, you can have a person, programmer inherits from person, and then programmer extends person. So you'll hear those types of terminologies. The child object can pick one or more parent methods and redefine and customize them for their own needs and things like that. So that's called method overriding. And then polymorphism. Again, we had the inheritance example of programmer and person. But a person can provide an eat method. The programmer can do that as well. But we could have a variable in my example here called Clay, and we don't know if Clay is a person or programmer object. We can still call the eat method, so it morphs there. Now I have a couple examples down here in this table where I have an example here. Clay is a man. He is an object. His date of birth, his gender, his hair color, those are properties. He can eat, sleep, talk, calculate his age methods based on another object. That's prototype. So just go through these. These will help get you to understand. You'll probably, if you remember your OOP classes, you'll understand some of these pretty easily. It'll be a small learning curve, but I wanted you to understand some of the nuanced differences with JavaScript. Now, in 1.1 assignment 2, which you can get to here by clicking this link, or you can go up here and click it up here as well. Same thing as previous assignments. I reserve the right to make some changes as necessary and make sure it meets coding standards. Put your information in here, but here's where we're actually going to do this. Again, I want you to follow all previous programming and coding standards. I want comments, flowcharting as necessary. This particular assignment probably won't need too much of a flowchart, but anything necessary to get good, proper code. So in this scenario, it's Friday, August 7th, 2015. You, the student, you go to Marathon County Humane Society, you look for a new pet. You selected one. Spoke to that staff member at the Humane Society, filled out all the paperwork. Then you took your newest member of your family home, whatever your pet was, and began incorporating that pet into your life. So imagine this is the scenario. Now I want you to imagine, because the reason object-oriented programming can be very powerful is because it emulates real world as much as possible. So imagine that scenario that you just see on your screen that I outlined is a program. I want you to write code that will build a table that explains the object-oriented principles that you can pull out of that scenario. So I've got that demonstrated output in that table. If I click on that, so here's that table that I showed you from before. So I've already demonstrated some of that, but I want you to pull out, and the entire table you need to build using JavaScript. I don't want you to mess with the HTML. So I output a table of 2 columns, one for the example, one outlining the principle, kind of like I did. And it needs to outline all of these OOP principles that I have bulleted here. Out of that scenario, you need to follow coding standards, comments, all that stuff, and it just needs to output here to this file. You can use 1.1 assignment2.js. So again, this is just to get your mind thinking about how does my programming emulate real world, and how can I do things to make sure it emulates real world as much as possible. If you have any questions, let me know, and happy coding.